Okay, second speaker for this session is Dillon Brown. He's a project geologist at the Geological Survey of South Australia with a specific interest in geochronology and petrology. Dillon joined the survey in 2022 after working in mineral exploration in South Australia and is currently completing his PhD at the University of Adelaide, which looks into the metamorphic expression of rocks from southeastern Australia and Antarctica. But closer to home, he will take us now through a multi-method geochronology from the central, new multi-method geochronology from the Central, Western and Gawler Craton. So thanks, Dillon.
Thanks, Anna. So what I'd like to cover in my talk are some new zircon shrimp dates that we've recovered from the Central, Western Gawler Craton. And what we've inferred these dates to mean is essentially to date the timing of mafic magmatism in the region. And so this project forms part of the Gawler Phase 2 program, which Rowan spoke about earlier. And just broadly, this program, the aim of this program is essentially to provide a better understanding of the mineral systems in the region through the acquisition of new geophysical, geochemical, geochronological data sets, and mineral systems, especially those that host commodities such as gold, nickel, copper, and platinum group elements. So I'm going to be talking about some zircon data. We've also dated apatite from these mafic intrusives, but for this talk it'll just be about the zircon. So why mafic magmatism? Why date these mafic intrusives? It's, as it probably comes as no surprise, it's because of this potential connection between mafic magmatism and nickel, copper, PG mineralisation. I don't want to dwell on the details too much, but essentially the systems that are best conducive to this type of mineralisation, typically extensional. They require a sustained thermal input from the mantle, and we need these kind of broad-scale lithospheric structures to accommodate that magma ascension into the crust. Importantly, there are two different types of or styles of mineralisation that we might find. That's those associated with chematic flows and those that are intrusion related. So why date mafic intrusions? Why in the Central, Western Gawler Craton in particular? I mentioned chematic type mineralisation. In the central part of the Gawler Craton, we have the Harris Greenstone Belt, which is given here in this green highlighted area on this TMI map. It contains chematites associated with basalts that contain nickel copper sulfides. And while there's no economic mineralisation in the region, we do have a well-constrained age for the Lake Harris chematite at about 2520 MA. If we move to the west, in the Fowler domain, we see intrusion-related mafic rocks that certainly have potential for mineralisation, and these contain both massive and disseminated nickel copper sulfides. And so they're exploring out there for metagabbroic and pyroxenite lithologies, and there's definitely been some recent success in terms of the exploration for this type of mineralisation. Now, if we go into the Eastern Christie domain here, up here, this is with the focus of the geochronology in this talk. So if we look at the Aristarchus prospect, the Scoos Hill region and the Acacia East prospect, there are also mafic intrusions that contain nickel copper sulfides, but importantly the timing of these intrusions hasn't been constrained. So I'll focus on these for the remainder of the talk. And as well as, I guess, determining the timing of emplacement of these intrusions, the other broad aim is to place all of that into a tectonic picture. So I guess most of the Central Western Gawler Craton falls under what's called the Archean early Paleoproterozoic Mulgathing complex. And this simple schematic here, I guess, tries to put the known units of the Mulgathing complex into a really simple tectonic picture. So I'll go into a bit more detail in a few slides' time, but essentially what previous work has interpreted is that we have an extensional back arc system and we have a sustained mantle heat source that's facilitating our extension. If we go back into, If we go into the Archean, we have the extrusion of the Devil's Playground volcanics. Around the same time, we get the deposition of the volcaniclastic Canela gneiss and the sediments of the Christie gneiss. We get the extrusion of the Harris Greenstone belt at 2520 MA. And then we get a series of more felsic intrusions such as the Glenloth granite, the Marbella tonalite, the 2475 MA Aurora tank suite, and we also get the emplacement of the Burden metagabbro that was dated at 2490, and that actually occurs at Aristarchus. And I did preempt this before, but it comes to this question here, which is simply how does the mafic magmatism recorded at Aristarchus, Scoos Hill and Acacia East fit into this simplified interpretation? So starting with Aristarchus, this is one of two samples from Aristarchus, plagioclase aurgite bearing metagabbro. It seems to be associated with the 2475 MA Aurora tank suite. Not granite. Oops, I've done it again. Okay. So that photo of our drill core here, we obviously have our metagabbro and it's associated with our granitic material here. So this Concordia diagram on the right here, it's a bit complicated, but essentially the main takeaway is that we've been able to recover two dates. The first is a inferred magmatic date at 2472 MA, and that corresponds to these bright zircon cores. And the second is a comparatively younger inferred metamorphic date at 2426 MA, corresponding to these darker rims here. Moving on to the second Aristarchus sample, the results are actually very similar. I wanted to include it just to show that these rocks are petrologically diverse. This has a significant amphibole biotite overprint. You can see in this MLA map here, we have a lot of green, that's amphibole, the brown is biotite, and there's kind of minimal evidence of relict aurgite, so minimal evidence for magmatic minerals. And as I mentioned, the age is very similar to the previous Aristarchus sample with an inferred magmatic age of 2467 MA and a metamorphic age of 2428 MA. So on to Scoos Hill, we sampled an amphibole plagioclase biotite amphibole. It could potentially intrude migmatitic lithology, which might be the Christie gneiss. And the data is quite straightforward, it's nice and concordant. We have, very similarly to the previous samples from Aristarchus, an inferred magmatic age of 2469 MA and an inferred metamorphic age of 2438 MA. The results from Acacia East, which obviously Alicia just spoke about, this is from the same drill hole, Acacia East 2. They're a little more complicated, so we sampled a charnockite, which is obviously not mafic rock, but what we see in drill core is that it appears to occur as these kind of patch-like domains within 2-pyroxene metagabbro here. Unfortunately, we couldn't recover zircon from the metagabbro, but what the data shows from the charnockite is a magmatic population at 2473 MA and a metamorphic population at 2442 MA. And I should say as well that with that magmatic population we've recovered, what we see in drill core is potentially, for the charnockite, it looks like it might be a late stage segregation from a predominantly mafic melt. So if that's the case, then that magmatic age at 2473 MA might also be extended to the metagabbro. So with those set of ages, which is quite a narrow range of ages, of magmatic ages, I should say, 2473 to 2467 MA from Aristarchus, Scoos Hill and Acacia East. Again, it's back to the tectonics. What do these mean in this picture? So in order to describe this, I thought it's worth going back and looking at the different stages of Mulgathing complex protolith development. So I should also note that the various stages I'm about to run through are based on a kind of synthesis of previous tectonic interpretations, geochronology, previous geochronology and geochemistry. So if we started about 2520 MA with the extrusion of the Harris Greenstone belt komatiites, that is thought to have occurred in probably the back arc of possibly a collisional system. So essentially we have shallow subduction at this time in the Precambrian, followed by slab breakoff, and that action of slab breakoff may have facilitated the influx of melt-bearing mantle to the base of that lithosphere, facilitating extension and thinning of that lithosphere and weakening. At this time, we also have the continued deposition of the protoliths to the Kaurna and Christiniases, and I should also say that prior to this, I mentioned the extrusion of the 2555 MA Devil's Playground volcanics. They're calc-alkaline and bimodal. So prior to this kind of scenario here, we may have had an arc kind of to the left of this diagram that's obviously subsequently been closed. So the period from 2520 MA now to 2480 MA, we now get, with slab breakoff, we now get this real significant influx of melt-bearing mantle to the base of the lithosphere, and that, widespread basin development. We get the intrusion of the burden metagabbro, which I've mentioned, at Aristarchus, and we also get a series of felsic intrusions such as the Glenlough granite mabellotonolite. And the deposition of the prolith to the Christinias is probably thought to have been terminated by about 2480 MA. Now on to what the results from this study really mean. So about 2480 to 2460 MA, we get the emplacement of the Aurora tank suite at 2475 MA, and the emplacement of our mafics from Aristarchus, Scoos Hill and Acacia East. It's interesting to think about at this time, around 2470 MA, there's also the onset of high-grade metamorphism, granulite facies metamorphism, associated with Sophotian orogeny, with metamorphic ages from both sediments and mafic intrusives as old as about 2470 MA. So the influx of mafic magmatism at this time may help promote high thermal gradient metamorphism as well. And just to wrap all of this up, I think there's definitely, from the data that we've shown in the new geochronology, there's multiple generations of mafic magmatism if we consider the burden metagabbro from Aristarchus at 2490, and then the results from this study around 2470 MA. We see regionally extensive ultramafic and mafic magmatism, thinking about the 2520 MA Lake Harris komatiite and the associated basalts in that region. And finally, work is currently being undertaken to assess the fertility of the mafics with geochemistry. So I'll leave it there. Thank you.